Okay, let me ask you this. Up until today, how have you been told you should calculate the average of things?
Where you would add up all your numbers and divide it by how many numbers there are.
Exactly. Okay, up until now, you've been told you add up all the numbers and then you divide by the number of numbers you added together. Okay, and that will get you your average, which is correct. With this caveat, with this exception, all of those numbers have to represent an equal part of the whole. Okay? So if I calculate the class average on a test or something like that, okay, I add all of your scores together and I divide by the number of people in the class because each one of you represents an equal part of the whole class. Well, that works as long as everyone's an equal part. When we're talking about physics, that may not always be true. So we have to calculate what we would call a weighted average. Okay? In case one part of the things we're adding together is worth more than the other. So let me give you an example of that. Let's say, we'll go back to our driving to Edmonton example, because that was such a debacle. Okay? So let's say I drive to Edmonton, and for the first 300 kilometers of the 320 kilometers, I am able to travel at 100 kilometers per hour. For the last 20 kilometers, there's construction, because it's May, construction. That's the month we're in for the next 6 months. Okay? For the last 20 kilometers, I can only travel at 50 kilometers an hour. Would I add 150 and then divide by 2 to get my average speed for the whole trip? No, because then it would say my average speed for the whole trip is 75 kilometers an hour. I went 100 kilometers an hour for 300 out of the 320 kilometers of the whole trip. My average is way closer to 100 than it is to 50. Okay? It's probably like 97, okay, or something like that. It would certainly be really close to 100 because that last little bit does not represent an equal part of the whole to that first part. Does everyone understand what I mean there? Okay. So when we're calculating an average in physics, we do this. So let's say I wanted to calculate the average velocity, like this question is asking, like the example I just gave you. Average velocity and average speed work this way. We say it's displacement divided by time, if it's velocity. If it's speed, it's distance divided by time. What that formula doesn't tell you is it can also be written like this. It can also be written as average velocity equals total displacement divided by total time. And the same is true for speed. It can be total distance divided by total time. Okay, so if a trip has more than one part, and I want to calculate the average, I put all the distances together, all the times together, and then I divide them. Okay, total distance over total time, or total displacement over total time. Okay, and the reason I bring this up is because oftentimes when I ask a question like this, people calculate the velocity for part 1, the velocity for part 2, add them together, divide by 2, because that's what they've been taught to do. Okay, the problem is that's not appropriate for this situation, because they don't represent equal parts of the whole like you all do for this class if I was calculating the class average. Okay, making sense? All right, so let's look at how this one here would work. Okay, so you guys have it all written down here. Okay, we have a bus that travels 100 kilometers north in 1.2 hours. Then it turns and travels 62 kilometers south in 0.9 hours. Okay, did they give me vector quantities or scalar quantities in this question? They gave me vector quantities. It has magnitude and direction. Okay, so what we're looking at here is a trip with 2 parts. So you want to write this down to kind of follow along. Okay, I'm still going to write down my givens, just like I did with the easy questions we did yesterday, but I'm going to break it up. into part 1, part 2, and my totals. So the information they gave me about part 1 was that the displacement, because it's a vector quantity, is 100 kilometers north. All right, so I'm going to write that here. D with the arrow over top is 100 kilometers north. Okay, and they told me the time was 1.2 hours. Okay, so that's what they gave me for part 1. The givens for part 2 are a displacement of 62 kilometers south and a time of 0.9 hours. Okay, now the question wants me to calculate the average velocity of the bus. Okay, so if it asks for average velocity, does direction matter? It does. Velocity is the vector quantity, speed is the scalar one. Okay, and they gave me displacements. They told me first you went 100 kilometers north, then you went 62 kilometers south. Okay, so I want to find my average velocity. I'm going to need my total displacement and my total time. Now, if we remember from yesterday, displacement is our change in position. All right, when we talked about the walking to Walmart and then back home, okay, when I got back home, what was my total displacement? It was 0, right? Because I went 2.8 kilometers and then I came back exactly 2.8 kilometers, and thus I didn't go anywhere. Okay? In this case, I go 100 kilometers north, and then I go 62 kilometers south. How do I calculate my total displacement?
100 minus 62.
Right, 100 minus 62 or 100 plus negative 62, okay? Either way will work, all right? But we have to recognize that one of these is forward or positive and one of them is backwards or negative, okay? So I would go 100 kilometers north plus 62 kilometers south, okay? And so that's going to end up being 38 kilometers north. Okay, so now I've got my total displacement. How do I calculate my total time? Half. Do I make one of them negative or do I keep them both positive? Keep them both positive. If I make a time negative, what have I done?
Lost time.
Yeah, or gone back in time. Okay, I went south, not back in time. Okay, there's a difference. All right, so because time is scalar, when I add it together, it can only get bigger. Okay, time can never get smaller. All right? So I would take my 1.2 plus 0.9 hours. Okay, so my time would be 1.2 plus 0.9, which would be 2.1 hours. Okay, oop, that's a speed calculation. I gotta get rid of that. That's going to be confusing. Okay, so now, do I have my total displacement and my total time?
Yes.
Okay, so now I can plug into this formula, yes?
Yes.
Okay, so my total displacement is 38 kilometers north divided by 2.1 hours. All right, so that means then that the average velocity of this bus is 18.1 kilometers per hour north. If you didn't put the north on that answer, would you get the answer right? You would not. And it wouldn't be a half mark off. Okay? If it's a vector quantity, it's wrong unless it has a vector on it. Okay? So we have to remember that. Okay, how would this calculation be different if I wanted to calculate the average speed? What would I do different? One tiny operation that I would change.
Instead of dividing, you would multiply? If we switch the positions of the B and
No, I wouldn't go to multiply. It's actually even simpler than that. Okay, time is scalar. The way I calculated total time won't change. My total time, regardless of whether I'm looking for velocity or speed, is 2.1. What changes about this? Somebody whispered it.
D. You would add them together.
You would add them together. Distance is vector or scalar?
Scalar.
Scalar. So does it care whether I went south and north? Just cares how far I went, right? Back to the Walmart example. When I walked to Walmart and back, my total distance was 8 kilometers, even though my total displacement was 0. Okay? So in this case, my total distance would be 162 kilometers. Then I'd divide by 2.1, and I'd get my average speed, which was the calculation I erased here a minute ago because I didn't want to confuse you. Okay? So 162 divided by 2.1, that's a very different number. Same trip, different points of view. Darth Vader betrayed and murdered your father. Darth Vader is your father. Okay? Two different points of view. Okay? They look very different, even though they're the same thing. All right. Everybody okay with that? Okay, so what if I didn't do it this way and I did it the way people have been taught to do averages? Would I get a very different answer? I would, because this part of the trip is much different and thus much bigger than that part of the trip, right? If I calculated the velocity here and the velocity there and then added them together and divide by 2, I'd get a very different answer. Okay? Because it wouldn't weight them. It would weight them equally instead of weighting them properly. All right, everybody okay with that? That's about as tricky as they get, except to maybe have a trip with 3 parts. Okay? But all it does is add one more part. It doesn't really change what you do. You just add 3 things together instead of 2. Okay? All right. Let's have you try this one. Okay? Very similar to what we just did, except this time it's a rabbit. Okay? So a rabbit runs due east at 22 meters per second for 12 seconds. And then turns around and runs due west at 17 meters per second for 32 meters. So you're getting some slightly different givens. You may have to do a couple of other operations to get what you need. Okay, we're looking for average speed. Okay, so total distance over total time and average velocity. Total displacement over total time. Okay, give you a couple minutes on that one, see how you do. Okay, so let's have a look at this. First thing we want to do is write down our givens according to the way the question is given them to us. Okay, so this question has 2 parts. The rabbit runs in 2 different parts of this trip here. Okay, so in part 1, the rabbit runs at a velocity of 22 meters per second east. How did I know that was a velocity and not a speed? Because they gave me a direction. It said he ran east at 22 meters per second. Okay, that means it's a velocity and not a speed, right? And he did that for 12 seconds. All right, then the rabbit turns and runs due west at 17 meters per second. So there's another velocity, 17 meters per second west. And does that for 32 meters. Now, even though they don't outright say west, they told me he ran at 17 meters per second west. He can't do anything other than go west, and he's doing that. Okay? Now, if I want to calculate his average speed, okay, because that's our totals over here, right? Okay, if I want to calculate his average speed, I need the total distance
and the total time. Well, I don't have the distance for part 1, and I don't have the time for part 2. But can I calculate them?
I can. I mean, I have
this formula that we used yesterday, right? V equals d over t. So I should be able to calculate the displacement for part 1 and the time for part 2,
because I have the other two parts of the formula.
okay? So in part 1, okay, I'm going to take that formula and I'm going to manipulate it for d. So I'm going to multiply both sides by t. All right, so v times t, 22 times 12. All right, 264 meters east. Okay, that's his displacement. How far distance did he travel in that part? It's a trick.
294, easy plus the 32.
No, just in part 1. But yeah, in total, you'd be right, yes, it'd be 294. Okay, but just in part 1, his distance is 264 meters.
I just don't put the east on it, right? He doesn't change direction during part 1, he runs east in part 1. That means he runs 264 meters east and runs a distance of 264 meters, okay? It's not like the Walmart example yesterday where we had to follow this crooked path to get to Walmart, okay? It would be like I actually walked straight through people's walls and houses and stuff, okay, and actually did that.
All right, for part 2, I've got to calculate the time. Okay, so I'm going to manipulate this formula now for time. So multiply both sides by t and then divide by v. So t equals d over v. So I'll have 32 divided by 17. Okay, so that only takes 1.88 seconds. Okay, that's a lot shorter than part 1, would you agree? Now that I have that information,
Can I calculate the two things it wanted me to calculate? Average speed and average velocity.
so if I want to calculate average speed, I'm going to need the total distance, okay, which Ryan already told us, okay, is going to be 264 plus 32, because it doesn't care whether it goes east or west, distance is scalar, right? So we're going to have 296 meters. What's my total displacement? If I go east 264 and then I go west 232, yeah, okay, I would subtract the 32 meters west from the 264 east. My total displacement's 232 meters east.
Okay. Is everybody all right with that?
Okay, basically what we're saying is the rabbit did this. Okay, went 264, then came back 32. That means that that's 232.
Okay, everybody okay with that?
All right. What do we do to get the total time? So in part 1, 12 seconds. In part 2, 1.88 seconds. What do I do with those to get my total time?
Add it?
Just add them together. Total time's 13.88 seconds. That's how long the rabbit's running for. Okay. Well, with that information, I should be able to calculate now average speed, distance over time, and average velocity, displacement over time. So average speed, okay, is going to be 296 divided by 13.88. Alright, so we're looking at 21.3. What are my units?
To get average speed, I divided 296 meters by 13.88 seconds. Meters per second, yeah. Okay, does that get a direction? It does not. Speed is scalar. The 296 didn't have a direction either.
Okay, if I want to calculate the average velocity, then I take my total displacement and divide it by the total time. So now we're looking at 232 meters east divided by 13.88 seconds. Okay, so 16.7 meters per second east.
Okay, have we done anything other than use V equals D over T? Well, actually, yeah, I guess we added and subtracted a couple numbers, but other than that, we use just V equals D over T, right? Okay, that's all we're gonna use for questions like this. Okay, we're gonna have to manipulate it, we might have to use it 2-3 times, okay, but it's all we're gonna use. Sometimes using it for parts of the trip, and other times for the whole trip.
Okay, so just a quick review here. Scalar quantities have magnitude only. So speed, distance, mass, time. Okay, those are all scalar quantities. Vector quantities have magnitude and direction. That would be displacement and velocity and acceleration and force. Okay, we'll get to those later. And energy is actually scalar, right? When we get back to that. But for now, displacement and velocity are vector, and distance, speed, and time are scalar. Okay, that one's too easy. So is that one. All right, give that one a try. It's easy too, but we'll give it a try. Okay, this one's not a two-parter. Okay, it's not like the ones we just did. It's like the ones we did yesterday. Okay, so with this one here, it says a bird flies 650 meters north. Distance or displacement? Technically, it's a displacement, but since this only has one part, it's also the distance if I don't write the north. Okay, so displacement's going to be 650 meters north. Okay, and it does so at a velocity of 9 meters per second north. Okay, how long is it flying for? So we're looking for t. Okay, so V equals d over t, and those are the ones with the arrows over top because we're dealing with the vector quantities. Okay, I want to get t by itself, so I'm going to multiply both sides by t, divide both sides by v, and then t will equal 650 divided by 9. Alright, so it's flying at 72.2 meters per second. That's very fast. A fast bird. Okay. Alright. Oh, sorry, that's supposed to be the time. That's not in meters per second, it's in seconds because the bird's flying at 9 meters per second. Alright. Is it important to remember units when checking things, unlike what I just did? Well, actually, I kind of copied them. Okay, 72 point, what was it? 0.2 seconds. Okay, so a minute 12. Right?
Is there a specific decimal you're supposed to go to?
For now, let's say I don't really care. When we talk about significant digits, if we have time, then there'll be some rules around how many things you keep. Okay, we may or may not get to that in Science 10. If we have time, I do it, and if we don't, I don't, because it gets taught to you right away in your first 20 level science. Okay, questions on those? All right.
This one's like the bus question. It's got two parts. The elevator is going up, and then the elevator is going down. Right? Give that one a try. Okay, so for this one here, okay, we want to write down again our givens part by part. So the first part of this trip is the upward part of the trip. Okay, so the elevator travels up 85 meters, so that's a displacement. Okay, 85 meters up. Remember, a vector doesn't have to be north or south. It can be right, left, positive, negative, up or down. Okay, it's any direction. And it does that in 30 seconds, so that's time. And then in part 2, it travels downwards 60 meters. And that's in 20 seconds. Okay, so this one's a little bit easier because I don't have any of those pesky intermediate calculations. I have the distance and time for both parts. Sorry, displacement and time for both parts. Okay, now for the totals here. Can I calculate my total displacement? I went up 85, I went down 60, my total displacement is 25 meters up. I'm still 25 meters above the ground if I only came back down 60 of the 85. Okay, so my total displacement is, not 65, 25 meters up. That's my total distance traveled. 145 meters. I went 85, then I went 60. Doesn't matter which direction, distance is scalar. Okay, so that's 145 meters. And then my total time, 30 seconds and 20 seconds is 50 seconds. Alright, well then I can calculate my average speed. Okay, average speed is total distance, 145 divided by 50. Okay, so 2.9 meters per second is the speed of the elevator. Okay, velocity of the elevator, okay, is going to be 25 meters up divided by 50 seconds, which is 0.5 meters per second. Up, just up. North and up are not the same. Okay, we're talking vertically up, not compass up. Yeah. Okay, everybody all right with that? Okay. All right, let's give you guys a 5-minute break here, okay, and then we'll look at some other ones we can. Okay, let's have a look at this one. So obviously metric conversions are going to be important in physics, okay? We do a lot of measurement, so we have to be able to fairly quickly convert hours to seconds, kilometers to meters, and vice versa, okay? All of that kind of stuff. So we'll be looking at a bit of that throughout. So looking at this particular problem, we've already done those conversions. I converted the time in hours, okay? So this was 1.1 hours, it's 3,960 seconds. 1.5 hours is 5,400 seconds, and 2 hours is 7,200 seconds. Okay, so we've done all of that stuff. Okay, we want to know what the overall distance traveled is and the average velocity of the elephants. Well, if I need average velocity, I need total displacement over total time. Okay, so I don't have the displacement in part 1, but I can find it because I have v and t. Okay, so that'll be v times t, so 3 times 3960. 3960. Okay, so 11,880 meters north. Okay, in part 2 I don't have to do anything because I already have d and t, but in part 3 I once again don't have the displacement, so I've got to calculate that, v times t, so 7,200 times 4.5. Okay, so they go 32,400 meters north. Okay, so can I get my total distance or total displacement and total time now? I can. All right, so to get my total displacement, I'm going to take 11,880 meters north. I'm going to subtract 7,000 meters south, and then I'm going to add 32,400 meters north. Okay, so the only one that's negative is the one that was south. Okay, and I'm going to divide that by 3,960 seconds plus 5,400 seconds plus 7,200 seconds. So the time for part 1, the time for part 2, and the time for part 3. All right, so if I do all of that, okay, so I'll take so we'll take our 11,880 plus negative 7,000 plus 32400. All right, so there's our total displacement, 37,280 meters north. Okay, and if we, sorry, I'll write that on here, 37,280 meters north. Okay, and then we're going to divide that by the total time, which is just those three numbers added together. Okay, so 16,560 seconds. Okay, divide those two numbers, and I've got the average velocity of the elephants. Okay, so the average velocity of the elephants is 2.25 meters per second, because I had meters on the top and seconds on the bottom. And what else do I need? All right, need a direction, because it's velocity. Velocity is a vector quantity. All right, now the other thing this question wanted was the total distance traveled, which will involve this same calculation with one tiny change. Well, I could change it to kilometers if I wanted to, but they didn't specify that they wanted kilometers.
Add 7,000?
Yeah, I just take that negative away, right? Distance doesn't care whether we went north or south. The only thing that changes is I add the 7,000 now, so I get the total distance traveled. All right, so I take the 37,280 there and just add 7,000 to it. Okay, or we can go 11,880 plus 7,000 plus 32,400. Okay, so we get 51,280 meters as the total distance traveled. Those elephants walked 51 kilometers. They're big, so it probably doesn't bother them that much. Okay. All right, questions on that one? Okay. Again, all we did was v equals d over t a bunch of times and some adding and subtracting. Okay, so nothing like mathematically challenging, but there's a lot of nitpicky stuff. Now, would I give you a question like that on a unit exam?
Possibly.
Oh no, I definitely wouldn't. Okay, here's why.
How many times did you use the same formula in that question? Like, what, 5 or 6 times? Do I need to see if you can do it 5 or 6 times, or do I need to see if you can do it once? Yeah, I might ask one where you had to do it twice, okay? But like, really, I'm not gonna do this on a test. That's not an effective use of time on a test. Okay, so to make you, hey, can you do the same thing and not screw up 6 times? Probably. Okay, so I wouldn't do that. All right, you know what? Let's call it there. We worked pretty hard today, so we'll call it there.